Good morning, friends. Welcome to our new demo session. In this demo session, we'll be covering the basic fundamentals of thermodynamics. Okay, so my name is Akhand Pratap Singh Yadav. I'm in currently in my final year of my graduation in chemical engineering at Sardar Vallabhbhai National Institute of Technology from Surat. I am from Varanasi, Uttar Pradesh. I have a relevant experience of teaching and doubt solving at Momentum Career classes in Varanasi during my summer vacation. So, to get a better understanding of fundamentals of thermodynamics, be with me for the next 15 to 20 minutes. Okay. So, we'll be starting our demo, our session now. So, we'll be starting our session with the first law of thermodynamics. Okay. First law of, let me choose the color of the pen. Yeah, fine. So, first law of thermodynamics. Okay, what does a first law of thermodynamics says? The definition says that it is the law of conservation of energy, which says that energy cannot be created, neither be destroyed. It can only transfer from one form to another form. So we can see the real life examples of first law of thermodynamics is basic are photosynthesis by the plants. Generally, they converts the sunlight energy into chemical energy. We can see the example as a heat engine, which also converts thermal energy to mechanical energy. Okay, so now we'll be seeing the mathematical equation of first law of thermodynamics. So it states that delta Q is equals to delta U plus W, which means for a closed system, the total energy of a system is always remains constant. So here Q is heat given to the system. Okay, and here U is internal energy of the system. Internal energy of the system, and W represents work done by the system. Okay, so we have seen the examples also and over them. So here we'll be seeing what is delta Q. It is internal energy of the system, which can be mathematically represented as mCp delta T. mCp delta, sorry, Cv delta T, which is a function of change in temperature. So now we'll be seeing the types of processes in the thermodynamics. So let's begin. No, let's begin with a question first. Okay, basically it's a very easy question of JEE Mains. What does it says? It says that a gas has a constant pressure in a system. Okay, okay, fine. There is a loss of 45 joule. Loss means the uh, 45 joule of heat in the surrounding, which means that the heat is released from the system to the surrounding. We can say Q is equals to negative of 45 joule. 45 joule and 450 joule of work done by the system, work done on the system, which says W, it will be equals to 450 positive as work done by the system. Okay, so we have to find the total energy, internal energy of the internal energy of the system. So we'll using the first law of thermodynamics mathematical equation, which says Q is equals to delta U plus W. Okay, fine. So we need delta U will be equals to Q minus W. What will be a Q? Q is minus 45 joule, and what is W? Minus of 450 joule. So it will be equals to negative of 495 joule. So internal energy of the system is negative of 495 of joule. It was a very basic question of JEE Mains. So now we will be covering the types of processes in thermodynamics. So there are many types of thermodynamics processes. We'll be seeing this by a PV. Sorry, it will be. We'll be seeing with the PV graph. It's P versus V graph. P versus V graph. So for a straight, let's suppose say this is also a process, and this is also a process. Any graph which can be made on PV curve, we can say it is a process. So will be this basic which are which includes in our syllabus. Will be seeing this is the straight line which says that the pressure remains constant, which means it is a isobaric process. Isobaric process, and this the hyperbolic graph will be equals to isothermal process. Isothermal process, and this is the graph of adiabatic curve, adiabatic process, and this is isochoric. So let's understand in deep the isothermal process. So what is isothermal process? It says the a system is said to be in isothermal process if the temperature remains constant throughout the process. Okay, throughout the process. Okay, so now we'll see the mathematical equation for isothermal by using first law of thermodynamics. What does first law of thermodynamics says? It says that the Q is equals to delta U plus W. So as we know that delta U depends upon m c v dt, so we say that delta T here is 0 as the temperature remains constant. So we can say delta Q is equals to 0. So it is the mathematical can be written as delta Q is equals to W. Okay, what does it means? That the amount of heat given to the system is equals to the work done by the system. That does just mean by the isothermal process. Now we'll understand the derive the formula of work done by the isothermal process. So what is the formula of work done? It is equals to W integral P dV. Now let's use the ideal gas equation. Ideal gas equation. What does it says? PV equals to nRT. As temperature remains constant, so we can also set PV equals to constant. So what does the it will have a PV PV curve. It will like a hyperbolic function. It's PV. Let's say here it's P1 V1, and this is V2, and this is equals to P2. Let's say a process is from V1 to V2. Okay, now we'll be seeing this since you know that it's P is PV equals to constant, so we can say that P is equals to nRT upon V. Let's put this in W. W is equals to integral nRT by V into dV. So nRT is constant, so we can remove it. It will be equals to integral dV by V, which is equals to nRT ln V. From where to where? It will be equals to, we are going from V1 to V2. So the work done formula will be equals to nRT ln V2 minus V1. Okay, fine. So also we can say that nRT ln V2 by V1. Since we know that PV equals to constant, so P1 V1 will be equals to P2 V2, or we can write as P1 by P2 will be equals to ratio of V2 by V1. Let's put this equation in here also. So W will be equals to nRT ln P1 by P2. This is also sorry. This is also a formula for work done, to calculate work done for isothermal process. Okay, got it? So we have this formula. So what are the real life example of isothermal process? We can say melting of ice. melting of ice at 0 degree temperature. So at 0 degree, it can be liquid also. It can be also a ice cube also. We have seen generally. Okay. So the temperature is not changed. Still, the process has been done, and the form of water is changed from solid to liquid. Okay. At 0 degree, melting of ice, boiling of water at 100 degree. We can say these are the real life examples of isothermal process. Okay. So let's have a question to understand better understanding of the this topic. So what does this question says? One mole, which says n is equals to 1. One mole of an ideal gas expands at constant temperature. Which constant temperature, which means isothermal process, and the temperature is also given, that is equals to 300 Kelvin. Okay, from initial volume. Initial volume, that says that the process is being from 10 liters to final volume V2 will be equals to 20 liters. Okay. So and the work done is expanding the gas, so we need to calculate the work done. Okay, we need to calculate the work done, and R is given that 8.31 joule per mole Kelvin. So from here we can say that the formula for work done is nRT ln V2 by V1. So we'll just put the formula here. W is equals to nRT ln V2 by V1, which is V final by V1. So we'll put the 1 into value of R, gas constant 8.314, into temperature 300 Kelvin, into ln V2 yani 20 by 10. So it will equals to 8.314 into 300 into ln 2 is equals to 0.693. Okay, ln. So the answer is 8.314 into 300 into 0.693. It will be equals to 172.9 joule. The work done by the system during this isothermal process is 1720.9, that is 1720.9 joule. Okay, so let's have a better understanding of adiabatic process. We'll be seeing this by a graph of PV curve. It is like this. This is adiabatic curve. What is a adiabatic process? Let's understand. According to adiabatic process, any process in which the heat remains constant. Heat is neither transferred from the system to surrounding, which means Q is not transferred and Q is equals to 0. We can see the real life examples are have you seen that Melton bottle or pressure cooker, sealed pressure cooker, their heat is not transferred, and by increasing pressure the food is cooked in the pressure cooker. So we'll write the mathematical equation by using first of thermodynamics, which says Q is equals to delta U plus W. Here Q is 0, we know. So delta U will be equals to negative of W. So for adiabatic process, it is equals to PV gamma equals to constant. Gamma is said the ratio of heat capacity at constant pressure to heat capacity of constant volume. Now, since we know that this will calculate the work done by the adiabatic process, that is W is equals to integral P d V. So from here, let's say it is equals to K. We can say that sorry, P is equals to K by V k power gamma. So we'll put here it is equals to K V k power gamma dV. dV and integrate, will integrate. So we'll have this integration as K V की power 1 minus gamma upon 1 minus gamma from V1 to V1 to V2. So we can say write this as ln K B2 1 minus gamma minus V1 1 minus gamma upon 1 minus gamma. So this is the mathematical formula for calculating work done by the adiabatic process. Adiabatic process. Okay, this is the formula of here. K is constant. Gamma is the ratio of heat capacity of at constant pressure to heat capacity of at constant volume. Okay, so this is the adiabatic process. Now, due to time constraint, I'll not be covering the other processes. So I'll just conclude my videos, my demo session. Okay, so we'll be concluding from here. What have we studied about thermodynamics? Thermodynamics means the thermo means heat and dynamics means motion. So basically, thermodynamics is a branch of physics which deals with the motion of heats. Okay, so we have seen the what is first law of thermodynamics and how does it work. What are the real life examples like photosynthesis, heat engines. Okay, and we have seen this question and what are the types of isobaric. So now we have a question that which process in among these four have the more work done. So what is work done? P integral PdV, which is just the area under the PV curve. Okay, so can we say that work done by isobaric process will be greater than work done by isothermal? Can we say that? As we can see here the area under isobaric curve is greater. Also it can be greater than work done by adiabatic, and the least is work done by isothermal process. Okay, and we have seen isothermal process where temperature remains constant, and we have derived this formula for calculating the work done. Okay, and we see in the adiabatic process. So with these I would like to conclude my video. I hope you got a better idea of understanding of what is first law of thermodynamics and types of processes like adiabatic and isothermal and many other processes. Thank you for being with me till now. Thank you.